Today we're going to focus our study on polygons, particularly on quadrilaterals. Now there are a number of different types of quadrilaterals and we're going to talk about them. So the first is a parallelogram. Now a parallelogram is a quadrilateral that has opposite sides that are parallel, opposite sides that are congruent, opposite angles that are congruent, consecutive angles that are supplementary, and diagonals that bisect each other. So taking a look at the parallelogram on the right here, opposite sides are parallel, so PQ and SR are parallel to each other, so are QR and PS. Those sides not only are parallel, but they're also congruent to each other. Opposite angles are congruent, so angle P and angle R, those two are congruent to each other, as are angle Q and angle S. Consecutive angles are supplementary, that means angles that are next to each other, so not the opposite angles, are supplementary. So P and S are supplementary, so they will add to 180 degrees. S and R are supplementary, and so on. The diagonals bisect each other. Now we haven't drawn them here, but if you were to draw the diagonal PR and QS, those two would bisect each other, which means that they would cut both diagonals. They would cut each other in half. Now in terms of notation, the way that we would notate a parallelogram, for example this one, PQRS, we would say parallelogram PQRS, so name it by all four vertices, and then when we write it, we would use this notation here. So similar to how for a triangle you draw a little triangle in front of it, for a parallelogram you draw a tiny little parallelogram in front of it. Take a look at example 1. Find the values of x and y. So because you know that opposite sides of a parallelogram are congruent, we can go ahead and say that AB has to equal CD, and substituting that gives us x plus 4 equals 12. Solving here, we get x is equal to 8, and so we found the value of x. Now we also know that opposite angles in a parallelogram are going to be congruent. So angle A is congruent to angle C, which means that y has to equal 65. So in this parallelogram, x is equal to 8 and y is equal to 65. Let's take a look at example 2. Find FG and the measure of angle G. So here, since we know that FG has to equal HE, we know that FG must equal 8. Now similarly, we can find the measure of angle G by looking at the opposite angle. We can say that the measure of angle G is also going to equal 60 degrees. Example 3. The diagonals of parallelogram LMNO intersect at point P. What are the coordinates of P? Now since P is where the two diagonals intersect, and since we said that when we draw in the diagonals, they will bisect each other, that means that we have created OP and PM to be congruent segments, and LP and PN to be congruent segments as well. Now what we can do is we can simply look at this diagonal OM and find the midpoint of OM, and that will give us the point P at which the diagonals cross each other, because since OP and PM are equal to each other, P must be the midpoint of the two. So to find the midpoint, you'll remember this is x1 plus x2 over 2 for the x coordinate, and then y1 plus y2 over 2 for the y coordinate. So this will be 7 plus 0 over 2, 4 plus 0 over 2, which gives us 7 halves, comma 2. So this is going to be A. Example 4. We're finding each of these measurements here, and the first one is NM. Now since we have a parallelogram, JKLM, we can say that NM, N being the point at which the diagonals intersect each other, NM must be equal to NK. If that's the case, if Kn is given to us here as 2, then we know that Nm must also be equal to 2. Now what is Km? Well, Km is going to be twice the distance from K to N, so that would be 4. What's the measure of angle JML? Well, in this case, since we know that angle JML and angle KJM, those two angles are supplementary. So since KJM is given to us as 110 degrees, then JML must be equal to 70 degrees in order for that to be equal to 180 degrees. Now what's the measure of angle KML? Well, since we just said JML is 70, and we see here in the diagram that JMK is 30, if we do 70 minus 30, that gives us angle KML, which is going to be equal to 40. Now there are some special parallelograms, and for all of these, the rules about parallelograms still apply, but they have some additional characteristics. So the first is a rhombus. So a rhombus, actually all the sides are congruent to each other. So everything about a parallelogram is still true about a rhombus, but it's a more specific type of parallelogram because all the sides are equal to each other. Next we have a rectangle. A rectangle is a type of parallelogram, but in particular, all the angles that are formed are right angles. And then the last one is a square, which is a combination of a rhombus and a rectangle in that it has all sides congruent to each other and all the angles are right angles. So that is a square, and you can think of it as being both a rectangle and a rhombus put together. Now there are some rules about diagonals pertaining to these particular parallelograms. So in a rhombus, not only are diagonals going to bisect each other, but they are going to be perpendicular to each other. And the diagonals don't just bisect each other, but they actually bisect opposite angles. So here's a picture of a rhombus, ABCD. And the diagonals you see here are perpendicular. You see that right angle that's formed. And then the diagonals also bisect not just each other, but also the angle. So they cut the angles in half as well. So they form all these congruent angles. Now in a rectangle, in addition to the diagonals bisecting each other, the diagonals are actually congruent to each other. So in this picture here, we see that AC and BD are congruent to each other. And then because they also bisect each other, we can see that we actually create 4 equal line segments. Now in a square, all 3 of these rules are going to work. So not only are diagonals perpendicular, diagonals bisect opposite angles, but diagonals are also going to be congruent for a square as well. Okay, so since we're talking about quadrilaterals, we're going to talk about a couple more, but just as a warning, these are quadrilaterals, but that does not mean that they are parallelograms. That means that they do have 4 sides, but they don't have any of the characteristics that we've been talking about up to this point. So first is a trapezoid. So in a trapezoid, this is a quadrilateral that has exactly 1 pair of parallel sides, and we call the parallel sides bases, and the non-parallel sides are called legs. So here's a trapezoid, and you can see here that BC and AD are parallel to one another, but AB and CD are not. But we call BC and AD, we call those the bases, and we call AB and CD the legs. Now each trapezoid has 2 pairs of base angles, and these are angles that touch the same base. Now a specific type of trapezoid is called an isosceles trapezoid, and in this, we have congruent legs, so AB and CD are congruent to each other. Congruent base angles, so angle A and angle D are congruent to each other, angle B and angle C are congruent to each other, and we also have congruent diagonals, so AC is congruent to BD. All right, and then the last type of quadrilateral we're going to talk about today is a kite. Now, a kite is a quadrilateral that has two pairs of consecutive sides that are congruent. Notice how they are consecutive sides, not opposite sides. And the opposite sides are not congruent. So here's an example of a kite. And as the name suggests, it looks just like a kite that you would fly. And you can see that on the right there, we have those two that are consecutive sides. They are congruent to each other. And on the left, we have two sides that are consecutive that are congruent to each other. Not only this, but the diagonals are perpendicular. So when you draw in BD and AC in this kite, we can see that they form a right angle right in the middle there, where they intersect. And then they have one pair of opposite angles that are congruent. So in this case, angle A and angle C are congruent to each other, but not B and D. So today we've talked about quadrilaterals, we talked about parallelograms, and we talked about 3 different types of parallelograms. And then we stopped talking about parallelograms and moved to quadrilaterals that are not parallelograms. So we talked about trapezoids, we talked about isosceles trapezoids, and we talked about kites.